But let's not focus on the word problems yet. Let's look at the front page, 1 through 10. Was there any questions on 1 through 10 that we could help you with? Anything on 1 through 10? Yeah.
Number 6.
Number 6, you got it.
What I did was multiply by the
Oh, okay.
then I got 6 equals 6 over 1. So then I said x equals.
I like it. Yeah. So this one, we do have a fraction and then a number. So we have half and then x. So another way this might be represented to you, it could be like this. That's the exact same problem. If I can write. Okay, that's the exact same problem, okay? But you could do one of two things. I could multiply by the reciprocal. So that's going to give me x equals 6. Or if it looked like this one, you just multiply both sides by 2. So it still works either way. So it's your choice which way you want to do it. They're both 100% correct, but however you see it. What else? Yeah?
We do 8.
8.
We done it last year, but I don't remember.
All right, number 8. Yeah, let me give you a pass. All right, you said number 8. Was that the one we're supposed to look at?
Yep.
Okay. Number 8. We have 3 is equal to negative x. So this could be written either way. I could have had this written this way as well. It means the exact same thing. Okay? You know, the letter coming first doesn't mean it's right. Okay? It's whichever way you want to see it. And I don't want to have a negative on the letter. So if I multiply both sides by negative 1, so I get negative 3 is equal to x, or the same thing as saying x equals negative 3. Either one of those answers is 100% appropriate, okay? There's nothing really in the rules of math that say the letter should be first. The variable should be x equals, okay? Yeah.
Doesn't you divide since it's negative 1x?
Oh, I could have divided as well. It's going to do the same thing. The negative 1 or the divided by negative 1, either one is going to change the sign. So it's going to get you the exact same answer. Absolutely. Good deal. Anything else on the very first page? Or are we okay? We good? So let's talk about the word problems. Okay, yes. If you do have a word problem in class, it will, during test or quiz, we will put it up on the board. We'll start the quiz, and I'll say, hey, we'll direct our attention in a few minutes to the word problem, and we'll highlight some things. I don't have these typed out on my thing already. Yo, easy. So the first one says, Natalie buys organic almonds priced at $27 from the grocery store. How much did she pay the cashier? She received $23 in change. Ooh. Okay. So let's think about this on number 11. This is how much it was for the almonds. And then this was the change given. So the person gave money, said, this is what I want to buy. The cashier said $27. The person gave a certain amount of money and got $23 back. So let's think about this. Okay. There was a certain amount of money given. Call that X. The almonds cost $27, and there was 23 change given. So that's basically what we're trying to get to. Okay? So what do you think? How would we solve that very bottom part? How would I get that X or that boxed in X all by itself? Yeah, add 27. So what do you think the answer was? That's on hand. 50. Yeah. So the person gave a $50 bill for $27 worth of almonds. That might be a lot of almonds.
I got the same answer, but I did it where it was like x minus 23.
Oh, okay. Mine got lucky. I like it, though. I like it. Cool. I see what you would have done. Yeah, I think that would have worked well. I like it. And it wasn't luck. It worked out nicely. All right. The next one says Rex and his friends are gaming online. Okay, it's just building the story. An hour later, 6 friends go offline. A total of 5 people continue to play. How many people, including Rex, were initially gaming? Okay. Let's see if we can figure this out. Rex and his friends are gaming. So you have these people that are at home. Yay! A certain amount of these people. One of these people is Rex. There might be more, but let's just pretend we have a bunch of people rather than drawing them all. Okay, Rex and his friends. Rex and his friends. Okay, so Rex and his friends are gaming. An hour later, 6 friends go offline. So at some point, there's a certain amount of people that are playing. 6 people go offline, and a total of 5 people continue to play. So a certain amount of people are playing. 6 people leave. 5 people are left. Well, looks like if I add 6 to both sides, looks like 11 people were playing. Can 11 people play the same video game? I don't know. I don't know these things. I don't play video games online. I'm sorry. You good? Yeah. Oh, thanks, man. 13 says Trevor takes up a test at school and completes it in an hour. The test has 2 sections. He takes 35 minutes to complete the first section. How much time does he have to complete the second? Okay, so 1 hour. How many minutes are in an hour? 60. Okay, 60 minutes. Okay, so I'm just kind of making some notes to myself, just making a mental note. There happened to be like 2 parts to this test that took 60 minutes for this person to do. Agree? So first part, page 1, turn it in. Page 2, 60 minutes. It says that one of the sections took 35 minutes. So the first part took a certain amount of time. The second part took 35. Or the first part took 35 minutes. The second part took how much time? So that we're going to solve that. How would I get to figure out how much the other page took? Subtract 35. So looks like, I think it's 25 minutes. So things to note about this problem. I made this conversion. I made that conversion just because I kind of knew. It's like, it takes an hour. Well, you have to know that 60 minutes are part of an hour. Okay, that's kind of an important part for that. Okay. And there's an awful lot of word problems here. So let's see. Clara has to climb a total of 36 steps to get to her dorm room on the 3rd floor. When she gets to the 2nd floor, she has climbed half the steps. Okay, hang on. Okay, so and a lot of times when I'm going to show you stuff, it's kind of how my mind is seeing stuff. I have to like kind of put some thinking down because I can't just, I'm not smart enough. I'm sorry. I wish I was a lot smarter. I wish I could just look at a problem and say, oh, this is the equation. But I don't have that. And so I apologize. Perhaps Ms. Stone has that and can see equations right off the bat, but I can't. I'm sorry. I'm broken. My mom dropped me. I don't know. So, all right, so I'm going to jot some things. I know that there are 36 steps that are part of this problem, okay? Hey, does this start sowing a little bit of thought? Just me writing something down? Is there, like, I've thought about something? So let's say I get to that point on this problem. Let's say this is a 3-point problem. And this is, I wrote this down, but like there's nothing else I can do. This is probably worth 1 point out of 3 versus leaving it blank. Like, I just put, I recognize there's something that's taking place, but I don't know anything else. Okay, so hang on. Let's see. Clara climbed 36 steps to the dorm room. This person's room is on the 3rd floor. They walked up the stairs, one set of stairs. They're now on the 2nd floor because you go 1st floor, 2nd floor, 3rd floor. There's one more floor to go. Okay? So as soon as they got, so let's think about this. I have to draw myself a little picture because, 1st floor, 2nd floor, 3rd floor. Okay, I'm drawing myself a picture thinking, okay, this is what's taking place. Okay, this person walks up a certain amount of steps right here, and then walks up another set of steps here. And once you walk up that 2nd set of steps, you're on the 3rd floor. Does that make sense? Okay, think about if you went from your basement and you have let's say you have a 2-story house and you have a basement as well, so there's really 3 floors. You went from the basement up to the 2nd floor. You go up one set of stairs to get to the main floor, and you go up another set. Now, I realize there's all different configurations of homes. There's split levels, stuff like that. But I'm just trying to think in this kind of situation. So I have a little bit more thought process I'm putting into this. I was thinking. And I'm going to kind of jot down a couple of notes that I know. It says there's 36 steps. So that those 2 green sections would have constituted 36 steps. It says, though, when our friend gets to the 2nd floor, so they get to right here, okay, they've walked half the steps. Okay, so I'm just trying to put a little bit more knowledge with how this problem could go. Okay, now I bet you we could answer this without doing math, without like doing fancy dancy math. I'm just doing some thinking. When they get to the 2nd floor, they have climbed up half the steps. Well, let's go back. How many steps did they take all the way to get to the room? 36. There's 36. Half of them were here. That means the other half are here to get to the 3rd floor, right? You don't have to walk up the 3rd floor stairs to get to the 3rd floor. You have to go up the 1st floor, 2nd floor. So technically, how many steps do you think, just logically, would have been on this first part and then the 2nd part? What do you think? Go ahead. Anybody? 18 and 18? That's what I'm thinking too. Okay? Now, again, my friends, I haven't done a whole lot of math. I'm just thinking this. It looks like there should be 18 steps to go. Now, let's say we want you to come up with some sort of equation. We want to come up with some kind of equation. So let's see if we can figure this out. This 18 and this 18 were not known. Agree? But we used a little bit of thought. So if we didn't know something, what should we call that in math? If you don't know, what? X, yeah. So I didn't know the 18 and 18 originally. So it would have been basically this green would have been X, this green would have been X, and X plus X would be X plus. How many X's? 2. 2X. So X plus X is 2X, and there's 36 steps. And then if I solve this and just went through it, oh, I see that there would have been 18 steps. Oh, so we did the problem logically, and then the 36 steps and drawing a little diagram, these are all thoughts. Do you have to have a picture? No. But in the mind of Stirrup, sometimes a picture might help me kind of get a little bit bigger picture. Okay? You're not wrong if you don't have to draw a picture, but there's no shame in saying, okay, I can kind of start stepping through this logically. Oh, I think I could do it. And then if we say, hey, we want the equation as well, the equation would probably be worth 1 point. So let's say you did the whole problem, you didn't show an equation. This would be a 3-point problem. You'd get 2 of the points because you didn't put the equation. But I don't think the equation was hard to figure out. It's like I had an unknown, I had an unknown. The unknowns are the exact same. So unknown plus unknown is 2 unknowns. Well, unknown in math is a letter, a variable. In this case, we just call it X. Okay, could have called it S for steps or stairs, but it's kind of your choice. Okay, is this making okay sense so far? And again, I'm trying to share with you because I was never told this when I was in school. I always thought when I was in school, I had teachers that would be like, oh, you have to make the equation. Figure out the equation first. And I'd be like, I can't figure out the equation because I have to give myself something to look at. I'm like, well, Chris, because my first name's Chris. Chris, why are you drawing this out? Because that's how my mind works. And there was a lot of times that I felt like I was doing something wrong. And like I knew some of the people in my class, and I'm like, hey, man, they ain't bright enough. I mean, they're as bright as a keyhole and as sharp as a marble, just like me. I don't know how to do it. Okay? And I'm saying that being sarcastically, but I kid you not. A lot of times when in my classroom with all of you, and I've done this for all my years of teaching, I just want you to know that everyone's mind's going to work a little bit different. Everyone needs a little different types of things to do in order to solve a problem. And it doesn't mean you're broken. That's huge to know. I really wish my math teachers, when I was in high school, kind of said, oh, Chris, yeah, I understand why you have to do that. You're thinking through it. That's okay. But I wasn't told that. I mean, there was times I'd sit there and have a test, and then I'd erase my picture because I think the teacher thought I was dumb. And I really felt that way. But I don't want you to feel that way. I like seeing that you have some logical thought. Whether you have a picture, whether you're an artist or not, it doesn't matter. You put your thoughts down. It's not wrong. Unfortunately, I want you to realize this is a comfortable place. I hope. Ms. Stone and I don't want you to feel that you're broken because you have to draw a picture that is related to the problem to make it work in your mind. It's okay.
I think still, even me as an adult, like I draw things like that too, because that's just how my brain works. But then sometimes I use an equation because I'm like, okay, that makes more sense to me.
Mm-hmm.
So like that's why we show you guys different options, because everyone does things very differently, right?
Mm-hmm.
But also too, that's the beauty about math, is there is different ways to solve a problem to get the exact same answer.
Mm-hmm.
So if you have a certain way that works for you and you want to tell us about it. We always encourage students, like if you figure out a problem a specific way and you want to show us, that would be awesome. So then we can figure out as educators, because we're always looking to figure out ways that are going to be easier for you guys to learn. It's going to be easier for you guys to understand. So if you guys figure out a way that's so much more easier and you show that to us, we encourage that, because we want to make sure that we're teaching you guys every type of way that we can. Make sense?
Yeah, and your mind is going to find one way or another to make it work. But it's just a matter of you trying. That's why we say on your homework, all you have to do is try the problems. And there's times that we might just, we're kind of quickly just looking at your homework. So we don't really have the whole picture. But there might be some times where, depending on who's looking at the homework, it's like, oh, I see. Okay. And I'll kind of make a little mental note saying, I just saw how this was done. Okay. Last word problem. Number 15. And again, whenever we get to a test or a quiz, yes, we'll read the problem out loud. We'll highlight some stuff. But if you still need a little more clarity, because, we think we're doing right by putting a little, ask us. We could talk through the problem. It's like, during the test, if we come over to you and say, Billy's got a question. Who's Billy? I don't know. Made a person in Stirrup's mind. It's like,
my cousin Billy.
Okay. Ask us. We're happy to kind of let's talk through a problem. A lot of times, hard thing is we are so used to communicating by talking. And I know a lot of you are communicating through social stuff on phones. Doesn't mean you're broken. That's the new thing. So, try and guide us along. If you're struggling with something, we can guide you. It's like, we're not going to necessarily work the problem out for you because we want to know what you know. But if something doesn't make sense, let us know. If we need to reread a problem to you, maybe you talk to us a little bit about the problem, even during a test or a quiz, that's okay. You're not broken. Okay? I learned this a long time ago. I don't believe in my heart that anything about education should ever be silent. It's about communication. Now, we don't want you communicating with your neighbor during a test or quiz because
That's cheating.
yeah, we don't want to have to fill out the paperwork. It's not fun. It's not fun for us. I tell you what, the worst phone calls that I have to ever make, it's like, hey, your kid, we caught them in the act of sharing answers or getting answers from their neighbor. Unfortunately, this falls under cheating. The person who was involved in it that wasn't getting the answer but was given the answer, that's called collusion of cheating, which falls under the same cheating category. We don't want to do that. It's not comfortable for us. Okay? Phone calls I like making, saying, hey, you know what? I really appreciate how hard Jennifer's working in my class. I know Jennifer still has like a 71%, but Jennifer's really working hard. I really like that. And those are really good conversations.
Those are our favorite ones.
Absolutely.
Because it's hard.
Yeah. So number 15 says this. It says, Jamie paid the rent well past the due date for the months of April? No, the month of April. So we already have a grammatical error. I'll have to change that. Oh, wait, the months of April, May, and June. Okay, see what happens? Stirrup doesn't read everything. So I think I'm making a grammatical error and a problem, and we was actually correct. Okay, so Jamie paid the rent well past the months of April, May, and June. Hey, how many months is April, May, and June? 3? Okay. So I'm going to kind of think that. I'm thinking right now, I just need to put a little, I know I'm talking about 3 months here. It doesn't matter what 3 months, it's just 3 months. So I'm just kind of logically thinking a little bit. So as a result, he had a total of $75 as a late fee. Okay, it doesn't mean rent was $75, but there was a late fee.
Oh my gosh, it's only 7.
For 3 months. Okay, now we could probably do this problem now that we have this information. We don't have any equations up there yet, but we have some thought. How much was the late fee each month if it was equal? What do you think? 25? Yeah. So you had 3 months. So 25 and 25 and 25. If I add those together, I get 75. Okay. So let's think about let's make the equation. So 25 is indeed the answer. $25 per month. That is the answer. But let's think about creating an equation. We didn't know originally for 3 months. If I don't know originally for 3 months, how am I going to represent that as math? Yeah. You think? No?
So could you do x plus 75 equals 3 and then do a 75? Or
Okay.
opposite side?
Okay, let's see. You said x plus 75 is equal to 3?
Or you could do the opposite way.
Okay. I see where you might have gotten that. Let's think about this. Question. Do we actually know these right now? Do we know that it's 25 and 25? I mean, we know it because we logically went through it, but if we didn't know it, what would we call those unknown 25s? X's or Y's or C's for cost or M for money? I don't know. So if I didn't know those, I'd have X and X and X and X. And if those are all being added together, if I go X plus X plus X, how many X's are we talking about? 3X equals 75. So you see where you might have made the error right there? You see where that error would take place?
What I did was I just put 75 divided by 30.
Oh, okay. So you technically you did the exact same thing that we were supposed to do. Yeah. So that's the long and the short of it. That's it. Friends, yeah. No, we're not throwing any extra fees in there. Nothing. We're just saying here's the fair money. But that's great thinking because yeah, in the real world, I bet you there are probably extra things that are hidden costs that called taxes and stuff like that. So we're not seeing that.
I just like
I would
the
just
car
like to say, I
cash,
wish my late fee was
the stuff for the gas.
Yeah.
And that's after 8
The
days.
tax for your home.
No, serious.
Basically everything, or for groceries.
Okay. So I'm on the next page. I'm on the next page of the notes. But what I want to do is I'm going to actually do each of these on an individual page. And I don't want you to write anything down yet until we get through the problem, okay? I'll give you time to write down the problem. Is that okay? Does this make sense?
Yeah.
So the very first problem on our notes would have been 2x plus 5 is equal to 13. Okay, so now let's not write anything down. Let's just kind of watch and let's see if we can figure this out. So basically, this means 2 times some unknown amount that's added to 5 is going to give me 13. Okay, so before we had been doing something called a one-step equation, meaning I had to do one math operation in order to get the unknown, the variable, the letter by itself. Now we have to do 2 things. So we're trying to figure this out. Now I know some of you might sit there and say, well, I might be able to do that in my head. You know, like, okay, if I go 2 times 1, that's 2. 2 plus 5 is 7. That's not 13, so it's not 2, or not 1. Maybe if I plugged a 2 in for x, 2 times 2 is 4. 4 plus 5 is 9. Well, that's not going to work. Maybe if I do a 3, 2 times 3 is 6 plus 5. 6 plus 5 is 11, so that doesn't quite work. Maybe if we tried 4, 2 times 4 is 8. 8 plus 5 is 13. Hey, so x must be 4. Okay? X must be 4.
We just got kind of lost. I did a little. I was like, whoa, that's some crazy math up in there.
Yeah.
When I thought about it, I was like, okay, that makes sense.
Yes. So and that's okay. So basically, I know that there are some of you that are like, I can do this problem. I just have to think about it. And you'll sit there and think, and you'll be doing the mental math. So basically, some people might choose to do this way. And if you went through it, you might have gotten this for answers. Okay? So this appears to be the answer. I think that x has to equal 4 in order for this answer to work. Okay? But that's not necessarily the right way. And this is why I don't want you to write it down yet, because it's okay to think. It's great if x comes out to a whole number. What happens if it comes out to some weird decimal or fraction? That becomes a little tougher to think through. Agree?
Agreed.
Cool. All right. So let's kind of look at the math way. Now, we taught you kind of a neat little skill yesterday. Hopefully it's a neat little skill. Maybe you've seen it before. We go with the equal sign. We kind of do a long line. So on our long line, we have one side, we have the other. We have the left side, we have the right side. Agree?
Agreed.
Okay, so let's see. I feel comfortable that this is the answer. So let's see what we could do in order to get that answer. Thoughts? Yeah.
Out of subtracting 5
Ooh.
on both sides.
Okay, stop there. I like your thought. So the thought is, what happens if we subtract 5 from both sides? Okay, so that means that because that's positive 5, because that's negative 5, they go away. Agree?
Yeah.
And that means that on this side, I'm left with 2x. And on this side, let's see, 13 subtract 5 is 8. 8, okay. All right, and then, hey, that looks like a one-step equation now. What do you think? Go ahead. Divide by 2. Good job, both of you. Good job. All right, so if I divide both sides by 2, those cancel, and x equals 4. Wait a minute, that x equals, oh wait, that's the same answer I got on both. Okay, now, I have a question to ask about this. Is on that far right side necessarily an incorrect way of going through the math?
No.
No, but on the right side is more of a survival. Okay? Like if you're taking some weird test, like, hey, you're going to take the ACT today, you're like, oh, great. That might be something that you might have thought through the problem to try. Agree?
Yes.
And survival math is okay. But again, if that value was a fraction or a decimal, it would be really hard to go through the survival method. So by us kind of realizing, so let me talk about this for a sec, because this is weird, and then I'm going to give you time to write this down. Remember this. We talked about it. We said it's a pretty good rule. Okay, so hang on. Parentheses, exponents, multiply, divide, add, subtract. So when we are solving, we're not going from top down, because look what I did first. What was the green thing that I did first? Subtract. And then what was the purple and red thing I did? So I went backwards on PEMDAS. And again, no one ever told me that when I was in school. Maybe they did. They didn't pay attention to it. That's possible. But notice, we went out of order of PEMDAS. We went from rather than going top down, we went from bottom up. We subtracted first, and then we divided. But does everyone feel comfortable that the answer should be 4?
Yes.
My friends, I feel that if you write this down in your notes, you might be good to go. What time we out here? 35? 5 minutes.
Oh, God, I was on another break. That's what throws me off. Yeah, 30 minutes.
Okay. All right, so my friends, we have time. We're going to do one more example once you feel you're done, okay? And then what we're actually going to do tomorrow is we're going to do the pretest, which the pretest doesn't count as a grade. We just want to see maybe if we have to move you up to accelerated. We won't move everybody because then we have nobody, and that's kind of lonely. No, I like that. No one ever said education had to be quiet. Don't move? Okay, you got it. You got my word, I won't move you. But I'll move all the guys around. I'm kidding. Ooh, that'd be a big jump. I would have to, if you were to jump to Algebra 2, I would have to give you the final exam for this class and the final exam for geometry. And if you got a 90% on all of them, all 4 of them, then I could move you to Algebra 2. 89 might be a conversation. All right. I'm going to try one more problem. One more problem. Okay. So this one might be a little tougher to try and logically do. So what's my first step if I was just going to solve this? Before I do addition, I like it. Yeah, draw the line. Our line's drawn. A little noisy over here. Okay, so it was brought up. We brought the line, and we felt addition would be okay to start with. What do you think? What happens? What happens to these 11s? They're gone. Okay, so I would get 4x, and then I get 17 added to 11. 28, okay. Last step is, I heard it. Divide by 4.
On one side or both sides?
Both sides, because those cancel, right? And we get that. All right, so my friends, I'm going to give you a lesser amount of homework tonight. Okay? A lesser amount. I would like us to look at page 15, and I would like you to try 1, 2, and 3. If you try 1, 2, and 3 for tomorrow.
Can I do it right now?
Yeah, I mean, we're almost out of here. We're out of here in like 3, right? Do you want more?
No.
Okay. Okay.
Probably just too much.
Try those 3. We'll go over those 3 first thing in the morning, or first thing class tomorrow. Then we'll do the pre-test, and then we will try and do some more of these tomorrow. How's that?